Good evening, everyone. I'm Chetan Dandekar from the AWS CloudFormation team, and this is the best practices session. And I have a few members from my team here, and we are not planning to do any dance here, but we do a lot of that under the covers. The purpose is that after this session, we would love to take your questions and take your feedback, and you can talk to any of us. So I just wanted to introduce my team here, and then we'll get started with the best practices session. The goal. Thank you. I know they work really hard to make this happen. The goal of this session is threefold. First of all, you are using CloudFormation because you want to reduce the time required and the effort required to manage infrastructure and applications. And I hope some of these best practices will help you reduce that time and effort even further. Second, even though CloudFormation automates a lot of tasks for you, you still need visibility into how CloudFormation does its work. And there are some tools here which will allow you to do that. And lastly, you want to be rest assured that when you are provisioning a stack, updating a stack, or deleting it, things work as expected. And then there are some best practices in this session which will help you ensure that. When you use CloudFormation, your workflow might look something like this. You design the infrastructure that you want for the business problem that you're solving. Then you model that in the templates, and you're also writing application code that will ultimately run in the stacks. And then you create the stacks, and you go over that process again and again to continuously improve your product. And this session is going to follow that general workflow. We'll see best practices in each of those stages. One of the first questions that you might have is, how do you plan your stacks? Should you model your entire architecture into a single stack, 20 stacks, 1,000 stacks? Should you use nested stacks ever? To answer that question, I have a few patterns here which are used very successfully by some of our customers. The first one is to think in terms of layers and environments. When you think about your AWS resources, they're very different. Their life cycles are different. The base network is not going to change as often as some of the front-end applications. So if their life cycle is different, they probably belong to a different layer of stacks. If the ownership is different, if a network admin manages the network stack and a web developer manages the front end, they probably belong to a separate stack. And there might be some shared services which have their own stack. So if there is a common database service that is used by multiple applications, you cannot bundle it with one particular application. You have to create a separate stack for it. And each layer could be one stack or multiple stacks based on the complexity. Once you have that layered architecture figured out and modeled into templates, then you can easily replicate it in your dev environments, or if you're expanding to a new region, in the new region. The next principle we see our customers apply very effectively is service-oriented architecture. I think every one of us is familiar with it. It's about dividing a big business problem into manageable parts. And each service, or that manageable part, is a unit of functionality and has a very clearly defined contract with other parts of the system. So if I imagine a food ordering business, they might have a service-oriented architecture like this. And the good news is when you go to create stacks to manage something like this, the stacks and their relationships will look exactly like this. You might have a food catalog stack and a customer DB stack. And they also have relationships. And how do you create those relationships? By using outputs and parameters. So if the food catalog stack requires some customer information. Then you can publish the customer DB endpoint from that customer DB stack and then pass it on as an input parameter to the food catalog stack. Nested stack is a CloudFormation feature. It allows you to reference on other templates inside a given template. And when you go and create a stack from that top-level template, CloudFormation will automatically create a tree of stacks based on the template's reference inside it. What is this good for? A prime use case for nested stacks is reusability. To take an example, let's say you have lots of websites which follow a common pattern, a common load balancing and auto-scaling pattern. Obviously, you want to maintain that pattern in one place and use it in all websites so that you don't have to maintain it in each of the website templates. You can do that using nested stacks. Have a separate template for ELB and auto-scaling and reference it in each of your websites. And it still gives you some level of customizability because the ELB and auto-scaling template accepts parameters, can have mappings, so you can still customize it to some extent for each of those websites. A second use of nested stacks is role specialization. So if you have multiple people in your team, you can farm out the work of creating templates based on their areas of expertise, and then still create a combined solution by hitting one button, creating a stack which creates a tree of stacks. Using CloudFormation is similar to any other software development process in that you code the templates, you try to create stacks, you hit errors, you debug those errors, and you finally get to what you actually want, a running stack. So are there any ways to minimize that time required to create a stack or reduce the errors that you hit? I think there are. The first way is to use the validate template API. The validate template API does some basic syntactic validation, like making sure the JSON syntax of your template is valid. It has all the right sections, like the parameter section or the resources section, and not an unknown section, or that it does not have any circular dependencies. When you're using the console or the AWS toolkits for Visual Studio and Eclipse, this is done automatically for you. But if you're using command line or calling the CloudFormation APIs directly or using SDKs, be sure that you use the validate template API. The next practice is using the parameter types. And this is very new. We just launched it last week. When we looked at the causes of stack creation failures, what we found is that a vast majority of failures actually happen because of bad input, garbage in, garbage out. So we decided to launch this feature, which allows you to avoid entry of bad input into the stack when you create a stack. It has two benefits. Number one, having these parameter types allows the CloudFormation console to provide you a much better UI. So for example, if I'm hosting a web application inside a VPC, I am likely passing in the VPC ID or the subnet IDs into the stack as parameters. And earlier, I had to look up a VPC ID somewhere and then copy and paste it or type it in when I went and created a stack in the console. Not anymore. Using these types allows the console to show you a valid list of VPCs in your account for the region that you're operating in. So there is no way you can pass in an invalid VPC ID. And this is also useful when you're not using the console. Let's say you have a continuous integration pipeline, and it is automated to call CloudFormation. This is still useful because when you use these parameter types, it allows CloudFormation to validate parameters right at the beginning of the stack creation workflow. Earlier, you had to wait a few minutes until CloudFormation went through its regular workflow and actually tried to create an instance that used some invalid parameter. Not anymore. If the parameter is invalid, it will be detected just in a few seconds, saving you a lot of time and effort and money. And while we are on the topic of parameters, here is another feature you should use to help your users pass in valid parameter values. In this example, this is an example from a template which creates a Windows server. And the scenario is that I want to limit the IP addresses from which the Windows server could accept remote desktop connections. So I'm passing in Cedar blocks as a parameter. And using parameter constraints, that min length, max length, and the regex for allowed pattern, I can make sure that the value passed in, even though it's a string, the value passed in is a valid Cedar. Keeping parameters aside, one of the most common causes of stack creation failures is insufficient permissions. So make sure that when you give your user permissions to create CloudFormation stacks, you also provide them permissions to create all of the stack resources that are defined in the template. Now, it might be the case that you don't want to give the user a lot of permissions. In that case, you can create an IAM role, give that role permissions to create all of the resources, and then have the user sort of request creation of stacks by using the identity of the IAM roles. Along a similar vein, when you make sure that your account has enough CloudFormation stack limits for a user to create stacks, also make sure that there is enough quota left for all of the stack resources, like the EC2 instance limit or the RDS storage limit. Ultimately, you are creating the stacks to run an application that drives your business. So how do you bring down that those application bits onto your stacks and start running the application? There are several ways of doing this. Our recommendation is to start with CloudFormation Init. CloudFormation Init is a template section that allows you to define the software that you want to install and start running when an instance boots up. And it has several benefits. It is declarative, it is updatable, and you can still bring in tools of your choice, like a shell script or chef recipes that you might already have. And I'm going to go through these benefits very quickly, but there is a much more detailed article available. So note down that link at the bottom to go to that article. And throughout the rest of the presentation, you might find these links at the bottom, which will take you to more details on the topics that we are talking about. Going back to CloudFormation Init, it is declarative, meaning you tell CloudFormation the state that you want to have, the packages that you want installed on the instances, the users that you want to be created, and so on and so forth, without having to worry about writing code that makes that happen. And if you have a highly customized configuration, which has to be captured in a script, you can still download that script using that files section in CloudFormation Init, and then using the command section to execute that script. CloudFormation Init is debuggable. It produces log files, which can be retrieved by SSHing into the instances, and they could also be streamed out of an instance. If you are familiar with the EC2 user data script, you would know that you can download an application and bootstrap it using the user data script. But once the instance starts running, you cannot change that application. The reason is the user data script can only be executed while launching an instance. On the other hand, if you use CloudFormation Init, it makes your application updatable. So for example, if I want to install an extra package or an updated version of the package on a running stack with a running instance, I can simply update the template and call an update stack on the stack, and then the CloudFormation daemon running on your instance will automatically pick up those changes and update the application. You still have the control to bring in tools of your choice. So in this snippet, I'm using CloudFormation Init to install Chef client and Knife, and then using a Chef recipe to install the application that I actually want to run on that stack. We support lots of different ways of authentication, using IAM roles, access keys, username and password if you want to download something from GitHub. Obviously, our recommendation is use IAM roles wherever you can. So to wrap up this topic of CloudFormation Init, first of all, use it. And second, when you do, there should be only 3 things in your user data script. Number 1, update the CloudFormation scripts. Number 2, execute CFN init script, which in turn executes that CloudFormation init section. And number 3, call CFN signal to return the outcome of the application configuration back to the CloudFormation service. So CloudFormation service knows whether to consider that stack create complete or create failed. Back in the old days, that means until July of this year, when some configuration failed, you had to SSH into an instance, pull out the log files, and look at the logs to figure out what's going on. Very painful. But in July, we launched CloudWatch Logs, which can pick up log files and stream them out of EC2 instances. And this integrates very well with CloudFormation Init. So if you are using CloudFormation Init, you're going to have the CFN init log file. In that configuration, you can start the CloudWatch Log service, the AWS logs, in the same CloudFormation Init configuration, and have it ship out the CFN init logs back to CloudWatch Logs. And once that happens, you can easily go to CloudWatch Logs console and look at the configuration logs by instance ID or by any other dimension that you want to use, making it very simple to at least go through the logs. You want to keep the stacks running as expected once they are created, and not worry about them at all. The first best practice to ensure that is to not touch it. It's kind of obvious, but how do you make sure that it is not touched unintentionally? You can protect a stack from accidental changes by using IAM policies pretty easily. Let's go back to the original layered architecture example. Let's say you have a very important network stack with your VPC settings, subnet settings, that you don't want accidentally changed. When your web developers are creating and deleting web applications, you don't want them to click on the network stack and delete it. You can do that by setting up IAM policy. Once you have the network stack, you can set this IAM policy which denies anyone access to that network stack to do modification on that network stack. And of course, when you actually want to do a modification, you can always disable this policy, and then once the modification is done, you can reapply this policy. And you can flip it around as well. If you have a set of web developers and you want them to touch only web applications, you can apply this policy to them and say, any stack that they create, modify, or delete has to follow this pattern. And one of the implicit things here is that for setting these policies, you need to follow a naming pattern in the stacks. So the best practice we saw earlier is good for protecting resources at the stack level. But how do you make sure that individual resources inside the stack are protected as well? We'll look at it in a minute, but first of all, I want to share that changing a stack resource outside of CloudFormation is never a good idea. For example, if you have created a load balancer through a CloudFormation template, you should not go to the console and change some properties on the load balancer. Two reasons for that. Number one, if you do that, then you no longer have version control infrastructure. You can no longer look at your templates and be sure that that's what is running in your account. And number two, CloudFormation doesn't know about it. So if you change something outside of CloudFormation and then come back to CloudFormation to run an update stack, the update might have unexpected results. Now, we understand that there will be valid situations where you would need to change a stack resource outside of CloudFormation. If it's middle of the night and if a server is crashing, you might want to go to the console and try a few different things. What we ask is that once that emergency is gone, make sure that you have a follow-up item to go back, undo those ad hoc changes, make those changes to the template, and flow them through CloudFormation, at least before you do the next stack update. Going back to how to protect stack resources using IAM policies, there are some ways. For example, if you are protecting any of the EC2 resources, including instances, security groups, VPCs, you can use tag-based IAM policies. If you have a group of console users, like in this example, you can put a policy on them that denies them the right to terminate an instance if the instance has CloudFormation tag on it. And CloudFormation tags any resource automatically with that pattern. So as long as that policy exists, nobody can change a CloudFormation created resource from the console. And one of the obvious things to keep a stack operating is to have a record of why a resource was created in a particular way. And comments are a very good way to do that. And you can have template-level comments or stack-level comments in the description section. And you can also have resource-level comments by using that metadata section that's available on every resource type. How do you update stacks safely? Our customers use both of these styles very successfully. The first one is in-place update, where you are updating a template and using that template to update an existing stack by calling the update stack API. The other style is where you take that updated template and create a completely separate stack from scratch, and once that new stack is up and running and working properly, you switch traffic or whatever workload you're running on the stack to that new stack. There are merits of both of these methods, and you should choose whichever fits your style the best. The in-place update is faster, obviously because incrementally updating a stack is going to be typically faster than creating a whole new stack from scratch. It's cost efficient because you're not creating a duplicate. And migrating application state and data that's there in that existing stack is straightforward because you're not changing anything in terms of data or state. Whereas in the other style, you need to figure out strategies to migrate application state and data into the new stack, possibly by creating a completely separate data stack. The merit of blue-green deployment is that at no point you are touching a working stack. If something goes wrong with the new stack, you always have that option to immediately fall back to the old stack. Can you have best of these both worlds? You possibly can. There are a few best practices which can get you there. We recommend that you follow the stack update checklist to make the in-place updates more reliable. Number one is to understand what resources are going to be changed. And this obviously means comparing the two templates, the original one and the new one, for obvious textual differences. And it also means being aware of the refs and get-ats, because those create resource relationships. And when you create one resource, it might have an impact on a related resource. Next is to understand how the update will be performed. There are three possibilities. Depending on the resource type and the property that you're changing, the update might have absolutely no interruption to the resource that you're updating. It might have some interruption, and in some cases, we may have to create a completely new version of the resource and then delete the old one. So make sure that you refer to our documentation to find out what kind of update it is going to be, and be sure that that is OK for your scenario. The next two checks on this checklist are very important from the perspective of avoiding update rollback failed state. Number one is to make sure that you give that user enough IAM permissions, not only to update the stack, but also to do the inverse of that update. The reason is, if update fails, CloudFormation wants you to roll back to the last known good state. So oftentimes we see cases where there is permission given to go forward, but if something fails during an update, there are no permissions to go backwards, resulting into an update rollback failed state. And the next practice is something we just talked a couple of slides ago, which is do not change stack resources outside of the stack and then update the stack. If there was a case where you had to change a resource outside of the stack, make sure that you regularize that change. You undo the change outside and put it through CloudFormation. And we just launched a service yesterday, AWS Config, which can help you with that. It detects any change to any resource. Eventually, it will be available in all regions for all resources. So you can easily find out what stack resources were changed outside of the stack. And there is always CloudFormer. You can use this utility to look at a changed resource and actually get a template snippet out of it. And then once you have that snippet, you can compare the current state of that resource in a template form with the template that it was supposed to be. And that way you know if the resource has drifted or not. Even if you are following those best practices for update, there might be oversight. So how do you avoid an unexpected change because of an oversight? Let's say you thought that you're not changing a database, but it actually got touched and something got changed. Stack policies help you to avoid those kinds of accidents. The example on the left side is a stack policy which locks all the database resources in a stack during a stack update. So if you have that policy applied to a stack and then a template comes in with a database change, the update will not happen. The example on the right side allows an instance update as long as the update does not result into deleting the old instance and creating a completely new instance. And the link at the bottom will show you more details about how to use the stack policies. Rolling updates is a CloudFormation feature which allows you to keep an autoscaling group in operation and still update it. CloudFormation does that by dividing the autoscaling group into batches. So if I have an autoscaling group and I want to make an update on it, you can use rolling updates to divide that into batches. And CloudFormation will make sure that at least one batch is healthy at any given time, doing the job that the autoscaling group is supposed to do. And we use things like, and you can use things like ELB health checks or any sort of test metrics that you might have to make sure that when a batch comes up updated, it is healthy, and then you can signal CloudFormation back to tell CloudFormation to go ahead and update the next batch. And rolling updates as a feature has been available for more than a year, so some of you may be familiar with it. What's good is we just launched an update which allows you to capture the whole process in a single template in an automated way. So you no longer have to put a pause time, first of all, guess a pause time and put a pause time between two batches of updates. You can configure a template to automatically go and check ELB to make sure the updated batch is healthy, and then signal CloudFormation back to go ahead and update the next batch, all in one template. Now, CloudFormation supports a whole bunch of services. We support over 20 AWS services today, and our intention is to continue expanding support for all AWS features and all AWS services. But what if you have a scenario where you need to provision something that is not yet supported in CloudFormation? Or you want to provision something on premises when you provision a CloudFormation stack. Or you want to provision something with a third-party provider when you provision a CloudFormation stack. How do you do that? There are a couple of different patterns that we'll see. The first pattern is to leverage stack events. Let me take an example. I'm provisioning a web application, and I want to use a third-party service that gives me web analytics. And I want to provision a subscription for that web application whenever I provision a CloudFormation stack. I can do that using stack events. I can have CloudFormation provision the web application, which is going to produce a bunch of stack events. Those can be easily delivered. CloudFormation delivers them to SNS topic, and you can write a little worker application that picks up those events. In this case, it will pick up the create complete event for the autoscaling group, and then pass in the message or write or execute the code that provisions the tracking ID or subscription in that third-party service. So this is a fairly simple way to achieve that extension. But there is no feedback back to CloudFormation. If the subscription fails on the third-party side, you won't get any response back right inside your CloudFormation stack. If you want a tighter integration, if you want to treat the external resource more as a first-class citizen of your stack, then you should use custom resources. I'm going to use the same example. You have a web application and the third-party analytics service. To use custom resources, step one is that third-party service provider has to implement a service capable of understanding create, delete, and update messages and executing the code that actually goes and provisions that external resource. Once you have that, you can represent that external resource inside a CloudFormation template, all in one template. And when CloudFormation executes that template, it will first create the web application. And when it sees that custom resource, it will send a message out to that service provider and wait for the response. When the response comes back in, then if it's a success, then CloudFormation stack creation will go on. If it's a failure, then you will get a create failed stack. So you get to treat the stack and the external resource as one unit of functionality which either succeeds together or fails together. Now, we looked at a lot of things that will make engineers happy. How do you make security people happy, or how do you get them off of your back really quickly? One of the ways to do that is to produce and maintain a lot of data. And fortunately, we do it for you. CloudFormation is integrated with AWS CloudTrail, which logs CloudFormation API calls, and it also logs the calls that CloudFormation makes to other services. And there is more good news, which is CloudTrail is integrated with CloudWatch Logs which allows you to query these logs and also set alarms on them. So for example, you can set an alarm which triggers when a particular stack ID, when somebody is trying to delete a particular stack and the deletion attempt fails, say, 50 times. You can always log those stack events into a data warehouse and then query them in any shape or form. And while we are on topic of audit and security, I want to share 2 more security best practices. Number 1 is there is no reason whatsoever to have secret keys and access keys in your templates. Anything that you can do with secret keys and access keys should be doable with an IAM role, and it is much more secure, and you never have to either pass in or hard code a secret key and access key in a template. And even when you need to pass in sensitive information into a stack, let's say it's a database stack and you want to pass in the default password, you should make sure that that parameter is marked no echo, and that tells CloudFormation to not surface that data in any logs or data like the stack events. The next is for the finance team. For a while, we have provided you a feature to estimate the cost of running a stack. Right inside the CloudFormation console, there is a link to go to the cost estimator, and there is also an API that allows you to estimate the cost of a stack. The new feature here is the one that allows you to track actual cost of a stack when it's running. Here is how it works. First of all, use that link at the bottom, which will tell you how to set up your monthly cost allocation report with tags enabled on it. And once you have that, you go to the new feature, which is the AWS Cost Explorer, and it allows you to slice and dice data in any way you want. And one of the ways you can slice the data is by tags. And as you know, CloudFormation tags each of the stack resources and the stack itself with the stack ID. So you can filter your billing for a given stack, and you can get insights like how much that stack cost in a month, and also you can look into the stack. So in this case, I can see how much of the cost is the EC2 cost and how much of the cost is the RDS cost in one stack. Now, CloudFormation is used by the full breadth of AWS customers, startups, enterprises, developers, IT admins, system integrators, ISVs, and there are even more ways of using CloudFormation and using it in a very effective way. And we obviously don't have time to go over each of those patterns, but before ending this session, I do want to share one pattern which is becoming particularly popular among our customers of all sizes and all types of businesses, which is integrating CloudFormation in a DevOps pipeline. Now, customers want to use DevOps because they want to ship software faster and with less errors. And they value CloudFormation because it enables DevOps even on the infrastructure. You can templatize the infrastructure that you want to create in AWS, and then you can apply all of these software engineering principles, code reviews, revision controls, integration testing, on your CloudFormation templates. If you look at their pipeline, this is how it typically looks. They have a group of application developers and a set of DevOps engineers, or there are many names for them. They specialize in creating building block templates, VPCs, subnets, and so on. And they also create a curated set of some higher level templates, like a generic PHP template or a generic MongoDB template, which helps the application developers get a head start in whichever application they're building. And both of these groups follow the same tool chain: issue tracking, using Visual Studio, Eclipse, any other development tool, code repositories which host the application code and also the CloudFormation templates. and they follow processes like code reviews. And they are using continuous integration. And that continuous integration server not only builds application packages, but it also packages the relevant CloudFormation templates with them. One of the things to note is that the generic templates go with the infrastructure developers, and the application-specific templates go with the application developers. So if I'm writing an application which needs a DynamoDB table, that's a very specific requirement. So I'm better off keeping that application template close to my application code. And once the CI server makes a build, anytime there is a check-in, the CI server is going to make a build. And then CI server calls CloudFormation to, first of all, use those templates to create a stack, and then deploy applications that are built along with the templates. And you must be familiar with the CI process where you would do that. You would do testing and then integration and eventually promote it to production. So that's all I have for this session today. And I have 3 requests for you. Number 1, please provide us feedback about this session. That's the top link. The second thing is, this is really a two-way process. I'm sure you have some best practices that we don't know about, and we would love to hear about them, share with other customers. So please contact us at that Twitter handle if you have any best practices. And whatever I talked about is documented in our documentation over there. Thank you.